Okay, so today I'm going to take this exam. Hopefully, this will help you guys if you have any issues with understanding your errors. And I think there's one error on the key, so I'll probably try to fix that. But this I'm just going to take this right now, so it's not going to be exactly the same as what you see on the key. Before we get into this, here are the grades. This is the entire class grades. This is called a stem and leaf. If you haven't seen this before. And so the way to read this is to say that, okay, somebody got a 25, somebody got a 25. So this is the stem, these are the leaves. So somebody got a 25, somebody got a 25, somebody got a 26, somebody got a 27, somebody else got a 27, 20, somebody got a 28, somebody got a 29, 29, 29.5. Okay, somebody got a 39, someone got a 38, somebody got a 38, somebody got a 49. Okay, so that's how you read this. So basically, these are all the grades. Okay, and I'll usually post these for transparency, so you can just kind of understand where you are relative to the class. I will say that generally speaking, probably, I mean, there's no way to say for sure, but if we stay the course, basically, these are probably going to end up being A's. Probably. Okay. These are probably B's. Probably. It's hard to say. And then C's and if nothing changes, C's and D's. Okay, in here. My guess is though that I can't really say what's going on down here. Okay. Sometimes, I mean, there are some people who like even I mean I can't remember specifically who got this grade, but sometimes like I look at something like this and there's some really good thinking here, but not enough to give you credit in the right ways, and so it's like, I can see some real positivity. Most of these people had some issues turning in the test or something, some sort of problem. So I'm not too worried. I don't really know what to think about this. Very worried about people here and here. Okay, very worried. So let's get it together. Come see me. Come talk to me. Office hours, whatever, and let's get this figured out. So that's all the grades. Let's not belabor that too much. And we're going to go here and we're going to start thinking about these problems. And like I said, there's a key online. So this is like I posted one to Moodle. But here's another key. I'm just going to take this exam and I'm going to explain, so it'll take me a little bit longer than it would take me otherwise. All right, so the specific gravity of a fluid, specific gravity, okay, if we remember correctly, specific gravity is, what is that? That's it's either the gamma of the fluid divided by the gamma of water, or it's the rho of the fluid divided by the rho of the water, is the product of the fluid's density and the acceleration due to gravity. So what they're saying is that SF equals fluid's density, acceleration due to gravity. Okay, that's not right. Okay, that would be correct if it looked like this, if it was the specific weight of the fluid. Okay, so if we were to correct that, we would make it the word weight. Right, so this would be false. Okay, capillary rise is higher in larger diameter tubes. That's false. It is lower. It is lower in large diameter tubes. Okay, gauge pressures can be negative. That's true. Okay, absolute pressures cannot be negative. Okay, the vapor pressure is defined as the pressure exerted by a vapor in phase equilibrium with its liquid at a given temperature. Okay, that is the definition of the vapor pressure. And the hydrostatic force on a gate, so what's that? F sub P, or whatever, force due to pressure. Usually it's equal to gamma H bar HC. I think your book is using HC, so the depth to the centroid times the area. So let's see. Hydrostatic force on a gate depends in part on the depth to the centroid. Well, this is the depth to the centroid right here, so that's true. Okay, for hydrostatic incompressible fluid, pressure does not vary with depth. Actually, pressure does vary with depth, right? So normally we would say like pressure equals gamma times H plus whatever the pressure is at the surface. Surf. Okay, so this H, that's the depth right there. So it does vary with depth. So true. Liquids tend to have higher bulk moduli of elasticity than gases. So basically the higher the bulk moduli of elasticity, the harder it is to compress. So that is a true. Oh, wait, the last one was false. Sorry. Yeah, some of you guys didn't guess on all of these. That was really annoying. There was a 50-50 chance. Anyway, viscosity is caused in part by the exchange of molecules between layers of fluid. That's true. It is also, so it's caused by two things. One is the exchange, and the other one is molecular attraction. If the vapor pressure is below the atmospheric pressure, the fluid will cavitate. I was interested in how many people missed this one because there were like 3 or 4 questions on that one homework assignment on this one. The fluids are going to cavitate only if the atmospheric pressure is below the vapor pressure. So this is false. So basically, these two would have to be switched. Okay, surface tension is caused by attractive forces between molecules. That's true. All right, so that's it. Okay, hopefully I did those all right. Never know, right? This stuff isn't easy, so let's not pretend. Okay, if the white surface, if this is air, blue fluid is water, red fluid is oil, and the green fluid is mercury. What is the difference in pressure between points C and D? Okay, so a lot of you went really weird on this. You did a lot of really strange things, some of which worked out, some of which did not. I'm going to do it over here. We're going to start with PC. Okay, so here I am right here. And what I'm going to do is I'm going to go upwards in the fluid to here. So going upwards, we're going to go minus gamma of oil times whatever that distance was, H3. Now I'm going to go from here to here, so that's a lateral move, so it doesn't affect the pressure. And then I'm going to go down, so when I go down, I add, and that's water, so I'm going to go gamma water, and whatever that is, that's H4. And then I'm going to go lateral to there. Okay, so no change, so that's going to give me equals PD. Okay, and that's really what I was expecting. People did a lot of interesting things. So if you bring PC over to the other side, you can solve this. And I'm going to like expand gamma oil is going to be S oil gamma water times H3 plus gamma water H4. Okay, at this point it's just plugging the numbers in, and that's it. Okay, so if you solve this, you end up with PD minus PC equals 2275.9 newtons per meter squared, which is the same thing as a Pascal. So PD minus PC equals, you could say 2.30 kilonewtons per meter squared, or kPa. Okay, I prefer kilopascals. Okay, I think specifically I asked for PC minus PD, so really this should be PC minus PD equals negative 2.30 kPa. Okay, so that would be the 100% correct answer. Okay, now, one thing you will know, this was worth 10 points. So the way I graded this one was basically I was looking for, did you know the correct way to set this up? So the answer was worth 1, which, basically you lost that point if you screwed up the units, or you didn't get here, or, whatever. But really it was +1 for this, +1 for the sign, +1 for this symbol. Well, really, I guess it was +1 here, +1 here. Let's start erasing things. Okay, +1 there, +1 for this sign, +1 here, and +1 there. All right, and then PD over here, +1. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. Okay, so that was all your 10. Okay, so total for the page is 20. Now, I did this one on the side because there's some interesting things you could have done here. And some of you started to do this, and it didn't quite work out the way you wanted necessarily. So what I'm going to do is I'm going to erase all of this, and I'm going to start over. And I'm going to do this a way that was, I think some people tried to do, and it just ended up being a ton of work. So basically they said, okay, so you want PC minus PD, so they decided they would try to solve for PC and then try to solve for PD. Okay, so if we're going to start at A, to get the pressure at C, I'm going to start at A. I'm going to say, okay, well, PA. Okay, we're going to go down in the fluid, but it doesn't matter because this is air, right? So, who cares, right? It's so not dense that we're not even going to worry about that. And then we're going to come back up H2. So we're going to go over, and then we're going to come back up. So we'll go minus gamma water, gamma water times H2, okay, equals PC. Okay, so that's one way to get PC, right? So I could plug that in. So I know the pressure at A is 100 kPa. Let's see, equals, well, let's work downwards, okay? Because this became a problem for some of you guys later on in the test. So 100 kPa, 100,000. Let's zoom in so we can get pretty close here. Okay, 100,000 newtons per meter squared minus gamma water, which is 9810 newtons per meter cubed, times H2. What is H2? H2 is 0.3. Okay, and you can get PC this way. So we'll say that PC equals, okay, 97,057, so 5 sig figs. Okay, now we want to get pressure D. Now, it still doesn't make any sense to me why we wouldn't go from C to D. But if you wanted to go all the way back to A, because this is the only known pressure in the whole system. Okay, but now we know two pressures, right? We know pressure at A, and I know pressure at C. So the easiest thing really would be to go from C to D like I did in part A. But you could have also started from here. You could have said, okay, PA. Okay, now we're going to go down to there, and that's air, so we're not going to worry about it. We're going to go over and up to C, so I'm going to go minus gamma water H2. Okay, now I'm going to go up, so that's going to be minus gamma oil times, what is that, H3. Okay, now I'm going to go over, doesn't have any effect. Now I'm going to go down, so what that's plus gamma water, H4. Okay, now I'm going to go over to D, equals not gamma, pressure at D. Okay, so I could plug in a bunch of numbers here if I wanted to. Noting that I already know what these two add up to because that's PC. And if I do that, well then obviously I get the exact same expression I got from the last one. Okay, but let's go ahead and plug in the numbers and we'll solve it just to prove. Okay, so it'll be 100,000. Okay, newtons per meter cubed. Meters squared, excuse me. Okay, minus. Okay, let's see. So we're just plugging and chugging here. 9810 newtons per meter cubed times H2, which is 0.3 meters. Okay, was that what H2 was? Yeah, it's right there. Okay, minus the gamma oil, so that's 0.86 times 9810 newtons per meter cubed. Oh, meters cubed times H3. H3 is 0.3. Okay, so that's this one plus gamma water, which is going to be 9810 times H4, which is 0.49, equals PD. Okay, so we could solve that. So it comes out to 99,333 newtons per meter, and then I can say, okay, well then, what are we looking for? PC minus PD. Okay, so that's 97,057 newtons per meter squared minus 99,333 newtons per meter squared. So PC minus PD, look, there's the negative sign, 75.9 newtons per meter squared. Okay, so PC minus PD equals negative 2.30, well, 2.28, I guess, 28 kPa. Okay, so that's the alternate way to do it. Okay, that's clearly longer than doing it this way, but you know, whatever works for you. Okay, actually, it looks like there's a rounding error over there, doesn't it? This should be 2.28. Yeah, 28. All right, so yeah, so that's kind of how that works. Before I continue, I'm looking at my notes. This is key. So sig figs here or here. Okay. Basically, I didn't take off if you gave me 4, but if you gave me 5 or more, I took off. Okay. So keep your sig figs under control. I want 3. Okay. Don't give me more than that. This is too many. Right. Nobody wants that level of precision or accuracy or whatever it might be. Nobody wants that. Okay. This manometer problem, this is key. If you could not do this one, and really this one almost came out like a trick problem based on the numbers, like how you guys did on this one, you must know this, okay? Must know. Otherwise, you're going to get nickel and dime for the rest of the semester. Okay, if you cannot do this, come to office hours. Let's get this figured out, okay? Also, just as an aside, a lot of you scanned your papers upside down or sideways. I took a point off for that. It really pained me to do it because I don't really like taking points off. But you really got to, it was also really, really hard for me to grade when you scanned it upside down. So I had to take a point in order to prevent that from happening again. So I apologize for that. But, I mean, it's just take a second to see if you scanned it right. All right. So anyway, so we're going to go over here. Let's see if we can, let's not do that. Let's do this. Okay. I've always wanted to walk on water like a water bug, but alas, I cannot. I am roughly 5.28 slugs. Okay, a slug, and I warned you guys about this on one of the videos, this is mass. Okay, I can't tell you how many crazy things I got going on with mass here. Okay, a lot of you are trying to convert this to pounds. Okay, don't do any conversions. Okay, you already know this. Weight equals mass times gravity. Take the weight, take the mass and multiply times gravity. What's gravity in this case? 32.2 feet per second squared. What do you get out? You get pounds. Okay, I understand that, slugs is not a unit we use very often, but it is exactly analogous to a kilogram. If you take a kilogram, you multiply it times gravity, you get newtons. You take a slug and you multiply it by gravity, you get pounds. Okay, it's exactly the same thing. You guys are doing a lot of unusual things that are just making your lives a lot more difficult. If I were to stand on a weightless circular disc, okay, so here's a circular disc. Okay, I'm going to stand on it. Okay, what would the radius of the disc need to be for the surface tension to hold me up? Okay, so the surface tension is acting kind of like right here, and it's acting all the way around. Okay, and it's hard to draw, but it's at an angle. Okay, and that angle is 60 degrees. That's really not very good. Okay, so that's 60 degrees right there. Okay, oh wait, no, sorry, this is 60 degrees. 60 degrees here. Okay, so, so it's not really very good. So we've got force of sigma, and it's acting all the way around this thing. And we've got a 60-degree force. And then we've got my weight acting downwards. And that's the whole thing. Okay, ignore any buoyancy effects. Okay, so what we're going to do here, and a lot of you just didn't want to draw a free body diagram. It takes like 2 seconds. You could have just done it like this. Force sigma cosine theta. Wait, that would have worked just fine. Anyway, so we've got force sigma cosine theta minus the weight equals 0. Okay, also I highly recommend you work downwards. Some of you guys are working all over the place, so what you do is you just replace things as you move down. So this is going to be sigma times L cosine theta minus the weight, which is mass times gravity. Okay, now I will note that the whole point of these questions is I'm always trying to figure out if you know what this L is supposed to be. Okay, the L is the length of contact between the water and the thing that it's acting on. So in this case, that's going to be 2 pi r. That's the perimeter. Okay, a lot of you put pi r squared. Okay, how do we know pi r squared is not a perimeter? Okay, because, I think, 2 pi r versus pi r squared, how do you know which one's which? See that? That is units of length. See that? That is units of length squared. Okay, so this is an area. This is a length. Okay, so the most important thing, so in this case, we want the perimeter, so we're going to use 2 pi r. Okay, we got sigma, we got cosine theta, we got mass, and we got gravity. Okay, so I think we now have all those things. All we need to do is solve. And what we're solving for is that r. Okay, so I think we could just plug in at this point. Okay, so it looks like that. And then if you solve it, r equals, I think, 10,889 feet. Okay, and to make that simpler, you know, I think you could probably even do like kilo feet here, but I would do 10,900 feet. Or really, I mean, in this case, it should almost go to miles. Okay, but that's 3 sig figs. Okay, note that's way too big, right? I'm not going to be able to find a disk that's 2 miles in radius, almost 2 miles in radius. Okay, so the way I graded this, basically, if somehow you showed that you understood that this was a force balance, some of you skipped straight to this step. Okay, if you somehow just showed that the two forces were balancing, that was worth 2 points. The answer was worth 2 points, so basically that meant, don't give me too many sig figs. Okay, so here I've written it with 3. And then let's see, so this is +1. This is +1, +1. Cosines +1, +1, and +1. Okay, and that's what it all boils down to. So 1, 2, 3, 4, whatever, it's 10 points. Okay, so that's how I graded it. Okay, so basically what I was doing is you have this number, and I'm looking to see that you used it properly. Okay, did you get the perimeter here? 2 points. Cosine of 60, that's a point. Et cetera, et cetera. Okay, so I'm just checking to make sure that you use these numbers properly. Okay, so that's how we did this one. All right. 2 parallel plates are moving in opposite directions at a speed of 5 meters per second. Wait, let me... the gap between the plates L is 1 millimeter and filled with oil with a viscosity of... Here's the viscosity. The plates have an area of 2 square meters. What is the shear stress between the plates? Okay, so I'm going to start over here, and I'm going to note... I don't want to work in red. Okay, that makes it look like I'm saying I'm wrong. Tau equals mu, du, d, let's call it z, z. Call this direction z. Okay, you can call it y, you call it x, you call it whatever you want, so it doesn't matter. Okay, so that's what we're looking for. Do we have mu? We have mu. Okay, what about du? What is the difference in velocity between these two? Well, they're both moving in opposite directions at 5 meters per second, so we have those. What about z? We know the difference in height between the two. Let's see, because they're 1 millimeter apart. Okay, so this one, tau equals, well, mu is 0.2 newtons times seconds per meter squared. Oh, there's a typo. That should have been superscripted. Okay, du, so that's the difference in the velocity between the top plate and the bottom plate. So top plate's going at 5, the bottom's going at -5. So 5 meters per second minus a -5 meters per second. Okay, divided by dz, the difference between the top. So the top is at 1 millimeter, 10 to the -3 meters, and the bottom is at 0 meters. Okay, boom. Okay, plug and chug, we get 2,000 newtons per meter squared. Okay, and so the units, some of you had a little trouble with the units, and I was actually mostly proud of you for even checking the units. But notice here, these meters on top and these meters on the bottom go away. Okay, and then these seconds here, they're going to cancel out with these seconds, and you're going to be left with newtons per meter squared. Okay, so, or tau equals 2,000, or 2.00 kPa is really the best. Okay, so that would be it with 3 sig figs. Okay, I accepted 2,000. Anyway, so the one thing, and I underlined it in red, this right here is a red herring. Okay, it's a red herring. Okay, meaning it's something you just didn't need. The other thing I'll note, and this is just kind of a general thing I wish I'd said right at the beginning, a lot of you started writing given and required and solution. Okay, not necessary on a test. Okay, just try to be smart about your time. If it helps you to do that, by all means do it. But it is a time sink, so just be aware of that. Okay, and some of you have trouble finishing because of time, and if you're spending all your time copying this stuff back down, that's just not a very good use of your time, unless it helps you again. Okay, so let's go find the last problem. This last problem was a bloodbath. I didn't intend it to be. What I ask of you guys, what I suggest is that we think about things that we know and think about things we understand. And when we get a problem that we haven't seen before, think about the things that you know. Okay, so here's the free body diagram. So I'm not going to read the problem to you, but here's the free body diagram. Okay, there's a hinge right here, there's a wall right here. Okay, now very few people did this. Some people wrote a free body diagram, but they forgot about HX, HY, or HZ, because I like Z to be up. There's a stop right here, so there's a, I guess we'll call it SX. And then we've got the acetylene, which is pushing this way, H, I guess we'll call that, not H, FA. I should probably be consistent with what I had on the key. Let's try to be consistent with that. I think I called it FR, meaning the force on the right. And then there's a force on the left. Okay, so we've got a lot of forces going on here. And so a lot of you tried to just say, well, when FL equals FR, then this thing's going to open. But that's not really the case because we have other forces. Now, I want to note that as the water rises, the point where this thing starts to open, at that point, this force right here, this SX, it goes away. Okay, because right when it starts to open, the stop is it's no longer touching. Okay, so that force goes away. So we don't need to worry about that one because that's kind of the point we're asking. Okay, so the other things we want to label in this diagram before we move on, though, this right here, what is that? Okay, well that's the moment arm, but what is it called? Oh, I didn't do a full free body diagram on the key online, but so I'll have to get at that. But anyway, so from the surface of the acetylene, which is like right here, okay, going down, there is a YP on the right. Okay, from the surface of the water, okay, going down this way, there's YPL. Okay, so those are the depth to the center of pressure on both sides, okay, and those are the things we need to solve for. Okay, so here we go. So this is the left rectangle. Here's the right triangle, the right rectangle. Okay, and so the left one, what's the area of the left one? Well, I don't know, right? It's got a height, H. Let's see, it didn't give us a width, so I'm going to call the width lowercase b. I don't know why that's pretty common, but that is pretty common. You could use lowercase w if you wanted to. Okay, so the width would be b, and the height would be h. That's the area of this one. Okay, where is the centroid? The depth to the centroid. Okay, well, let's see. That's going to be halfway down because it's a rectangle. So that's going to be h over 2. Okay, what about YC? Well, YC and HC are in the same direction, so that's the same thing. Okay, so that's going to be h on 2. Okay, now we need the I think your book calls this XX comma C. Okay, so that's going to be 1/12 the base times the height cubed. Okay, which in this case, I can't solve it more than that. So this is annoying, but whatever. There you go. That's where we are. Okay, we can't do it any better than that, and that kind of is painful, but that's just how it works sometimes. Okay, so let's go ahead and do the right side here, and I'll get the area equals, well, let's see here, the area of this rectangle. It's got a height of 2 meters and a width of b, so that's b times 2 meters. Okay, the HC, well, that's going to be halfway down because it's a rectangle. So that's going to be 1 meter. So basically that's 2 meters divided by 2 equals 1 meter. The YC is the same because it's in the same direction. Okay, equals 1 meter. And the I bar, or the IXXC, I think it says your book calls it. IXX comma C, which is way long by my reckoning. So that's 1/12, the base. Now the height of this thing is 2 meters cubed. Okay, so that is going to come out to, let's see, so 2 cubed is 8, 8 over 12 is 2/3. So we've got 2/3 of a meter cubed times B. Yachi machi. Okay, not a huge fan of that. Okay, looks like my key has a little bit of a unit error there. But anyway, okay, so let's go ahead and solve this one. So the one on the left, we're going to do, because at this point now we've got, excuse me, FL. At this point we've got everything we need. So it's going to be gamma, in this case of water, HCA. Okay, so we can plug all of that in. So FL equals gamma of water, which is going to be 9810 newtons per meter cubed, times HC, which is H on 2, times the area, which is BH. Okay, so let's see. So FL equals, what's that, 4905 newtons per meter cubed times BH squared. Okay, I think some of you are a little afraid of variables. It's okay, they just carry through. Okay, it's no different than working with a number. Okay, so I'm going to do the FR over here. It's going to be the gamma of acetylene, HCA. So the FR, the gamma of acetylene is 0.38 times 9810 newtons per meter cubed. I'm going to plug in the HC, which is going to be 1 meter, and the area, which is going to be B times 2 meters. Okay, so FR equals, let's see, 7455.6 newtons per meter. Okay, because we've got it meters cubed here, we've got a meters and a meters, so meters left. And then we'll multiply that times B. Okay. All right, so those are the forces. And now we need to know where they act. So we'll say YC, this will be L, or YPL, I guess. Center of pressure, YPL equals YC plus, let's see, it's YCA on the bottom, IXXC on the bottom, I mean on the top. Okay, so YPL equals, let's see here, H over 2 plus, let's see here, 1/12 BH cubed divided by YC, which is H on 2, and A, which is BH. Okay, notice the B's cancel, which is really nice. Okay, B cancels. H squared cancels with, the two H's on the bottom cancel with two of the H's on top, so I just get a unit of H. And if you do the algebra here, you get, so this is H on 6, so this becomes 2H on 3, okay, which is cool. Okay, and then over here I'm going to do YPR, okay, which is going to be YC plus, same formula. Okay, so YPR equals, let's see here, YC is, see this side's a little bit easier because we have numbers. 2/3 m cubed times B, YC is 1 meter, and A is B times 2 meters, B times 2 meters. Okay, so the B's cancel, and we just get meters, and so we get 1 meter plus 1/3 of a meter, so YPR equals 4/3 of a meter. Okay, so if we go back up to our little free body diagram, okay, let me just redraw it down here. So I've got this little thing right here. Okay, now I've got, from the top here, I've got 4/3 of a meter, and then I've got this thing acting here, F, what do I call it, FR. And then over here, from the top, I've got something acting. This is FL, and this is 2h over 3. 2/3 of h. Okay, so, and of course I've got these h in the x and h in the z. Not that they really matter at this point, because we're going to sum moments around h. So the sum of the moments around h equals 0. So we've got FL times, so we need to know this distance to get the moment arm. So that's going to be h minus 2/3 of h, so 1/3 of h. Okay, and that's going to cause a, what's this direction? It's like a clock, so we'll go minus. Then we're going to add FR, and it's going in the opposite direction. And it's going to be 2 meters minus 4/3 of a meter equals 0, because this is its moment arm right here. Okay, and so if we plug numbers in for that, now I'm just going to kind of copy this from the key. Or let's copy from above. That's a smarter way to do it. Okay, so we'll get negative 4905 newtons per meter cubed times BH squared. Okay, times these two combined to become 1/3 of h, plus 7455.6 newtons per meter times B, times these two are going to combine to be 2/3 of a meter equals 0. Okay, so I'll do an intermediate step here, but one nice thing you can see right here is these B's are going to cancel out. Okay, so even though I didn't give you B, you didn't need B. But the intermediate step becomes negative 1635 newtons per meter cubed times, looks like this is going to be h cubed, plus 4970.4 newtons equals 0. Okay, so solve that and we'll get h equals 1.4486 meters, h equals 1.45 meters. A couple of you actually got the right answer with a lot of incorrect work, which I thought was really impressive. Let's see, so where were the points on this one? Basically, there were 2 points for this equation, 2 points for this one, 2 points for this one, 2 points for this one, and then 1 here and 1 here. So basically, down here you had to recognize that it was a sum of moments, and you had to recognize that this is the moment arm here. This is the moment arm, right? And get all the signs right and everything. Up here, basically, if you made 2 errors getting this FL right thing, then you got 0 points. If you made 1 error, then you got 1 point. If you got it all right, then you got 2 points. All right, so that's it, and so that's all the 10 points for this one. And let's see here. I think that's all my notes. Yeah, that's it. So anyway, the grades weren't good. There was some good thinking on it, but the grades weren't super great. So let's buckle down and let's get where we need to go. Okay. Remember, this class is hard, but we're gonna get there. So I don't know where the title of this one went. It's around here. There it is. So yeah. So grades aren't so good. I think the median over here was, if I look at it, where's my median? Median was about a 28. Of course, you could just count if you wanted to. I think this was the median grade. But you know, I'd be happier with the median. Well, really, I want the median to be, I want these guys to be the medians right in here. Okay, so that the worst, so the average student is an upper C, or really even a lower B. So really, if we could get it over here, that would be awesome. I'd be really pumped. And I think, from what I'm seeing on this test, there's a lot of ability in this class. I think we can do it. So let's just keep plugging away. All right, thanks guys. I hope this helped. All right, take it easy.